Good morning, dear children. So, welcome back to our class. Initially, we have started in this science, especially physics, with the chapter motion, right? So, in previous classes, we have talked about the motion or how the way we can understood the motion, right? It describes the way of motion of different objects. Then we understood the cause behind this motion. We understood different laws related to this motion, right? Even we understood the inertia on the basis of mass of an object. We lead to the concept of gravitational or gravitational pull. Accordingly, we lead to the terms like weight. How can we measure weight of anybody or any object, right? So we understood all these terms on the basis of different terms like describing motion, understanding the cause of motion, understood the gravitational force or gravitational pull, and now we have to understood the another concept which is very useful for describing or interpreting the natural phenomenon such as work. Yes, you can see on the board clearly. Today we will start with our next chapter in this physics, that is, yes, work and energy. And I have gone through the deleted syllabus, so I observed there is nothing which is deleted from this chapter. So it is very important term to be understood. Okay, we will learn it concept by concept with a example or with many examples so that you can actually understood the word work in scientific way in science. Okay, so in previously where we have understood gravitation, we also gone through a very important term there like relative density. Yes, do I have explained you it? Yes, we have explained that term relative density, and there we understood the relation of density with volume. Even I have explained you that with the help of scar, right? So what we understood, density is inversely proportional to volume, and relative density is actually the density of substance with the density of water, right? Yes, I know. Though this part of flotation from gravitation is eliminated, but it is only for the year 2019 and 20, right? So next onwards you have to study it, and thereby you have to remember all the terms as well. Or even for competitive exam, it will not be eliminated from there as well. So you should know this term. So relative density is the ratio of density of the substance to the density of the water, and it will be uniqueness. But mainly density is inversely proportional to volume. So suppose I have taken one example today here. Can you see my hand? Can you see the dots drawn here with the pen? Is that clear to you? Right? If I hold this palm stretched, these molecules are at a certain distance. Right? So what you will consider, the dots what I have drawn on the palms are same in the number when I will unstretch it, when I will fold my palm. So dots are same in numbers, right? Before that number was there, as I folded it, the number are same. Means, what does it implemented? Yes, the mass remain constant, right? Mass is what? Mass is inertia. Represent or we can measure inertia in a law of inertia. We understood that, right? But in practically, when we learn it deeply, it's actually the number of atoms or molecules present in that object, right? So thereby, yes, masses will remain constant. The number of atoms will remain constant as I folded it. But what happens when I have stretched my palm? The dots are separated, means the volume is greater, but they are at certain distance, means density is small, right? And as I fold my palm, the dots come close to each other, right? So volume reduces, but density increases, right? But in both the case, number of atoms remains constant. Means what? Your mass remains constant. Yes. In last video, I have explained to you it with the help of stars. But now I thought it is important to revise it once because it is one of very important physical quantity in physics which is going to be repeated again and again, right? So here we have understood or recap with that gravitational part. Okay. Now today, after this, as I already explained you, we have to introduce with a new concept which will help us to understand or interpret natural phenomenon like the word is work. Okay, and this word work is associated with two close words like energy and power. And thereby, in this chapter, we will deal deeply with the concepts of work, energy, and power. Okay, so without energy, we cannot understood the life of us is going, right? How? Why am I saying this? You all know that all living beings need food for energy, right? We can not live without food. And why we are eating or using this food? To have energy. And why we need this energy? To perform our task, to perform different activities to survive, to perform work, right? This activities performed by all the living beings can to survive can be considered as life processes. So various activities included in our life processes always need energy, and thereby it is important to understood what is work, how it is related to energy, and why we conclude it with the term like power, right? So let's begin to understand deeply the meaning. We cannot go directly to the definition, right? We have to first understood, analyze different examples, and then only we will define what is work. Definitely we have to define it, we have to use it further, but initially how we will lead to the concept, why we need the definition of work, right? So this word is related with energy, and we understood why energy, how energy is useful for us. Right? In this living being, if suppose I differentiated with human beings, we, you, me, right? So we are using energy for each work, each activity we are doing, each uh, particular life processes we are doing, like running, walking, talking, even reading, writing, right? So even you're humming some tune. So each and everything which are involved need energy, right? It is about us. Even though we differentiate, suppose animals, right? So they also using energy for each and every term. They have to find their food. They have to find their safe place to avoid enemies. Right? Even we are using them. Like animals are used for plough the field, right? In farms, or even we are using them to lift weights. We are using like camel is used in desert, horse is used in some places to lift the weights. Even we can do the horse riding. We can move from one place to another with the help of horse like animals. Bullock cart is used. So animals are also being used to have or carry loads, lifts or plug the field. Right? So they are also need energy, using energy for their particular activities to do. Now, coming to non-living thing. We can list the machines around you, right? You can initially see the mobile you are using right now. If your mobile is not charged, so are you able to watch this online video? No. You need that mobile to be charged, right? Means what you are doing. Yes, correct. Means what you are doing, you are charging mobile means you are providing energy to that mobile, right? So that the mobile can do its required or allotted work. If you are finding washing machine around us, it will be very helpful for your mother, for me as well, right? It will bring the many works for me like washing clothes or washing the heavy clothes especially, right? So the work if I will do, I need that energy. The work washing of clothes you will do, you will need the energy, mechanical energy. And similarly, if washing machine is replacing humans, of course you have to provide it electricity, right? Means it should have energy to do required work. Means now I cannot differentiate this. Even living things as well as machine needs energy to do their required works. Are you getting my point? It is something to relate now with the term like work. We have understood that it is living thing need energy. We understood it is machine need energy. But now initially we learned the concept of work, and work will lead us to this energy. Yes? So now pay attention to the word property that is work. What is work? Not going directly to the definition. Just pay attention to the explanation which is logically understand. Because this word work is used in different manner in day-to-day life. But at the same time, this word work is used in different manner in science. Yes. How can we differentiate it? Let me give an example. See, right now we have done with our MCQ examinations, right? Yes, I know you all have enjoyed that MCQ examinations. You have worked hard to do your required studies, right? You were sitting on the table, you were understanding the concepts behind that words, the sentences, but how that sentences returns on the board, books, and you are reading books. You are doing a lot of work. You are reading book. You are correcting your thoughts. You are drawing diagram. You are trying to write derivations, and you are doing numericals sitting on the table and the chair, same from morning to afternoon, and you got your beautiful results with you. You have seen how marks are in different subjects in total we will display you, but in that you have done a lot of work, and I'm really appreciating your work that you are very serious about your studies, right? Even apart from examination, in daily life you are doing a lot of work. You are sitting in front of your mobile computers and you are continuously watching the videos, not missing. You are interactively chatting with me, typing the terms what I am asking you, right? So you are making the class interactive only because of you. You, the students, you, the children, are making this class beautiful, right? So I'm really appreciating this terms too, and you are doing a lot of work for me. In day-to-day life, you are doing a lot of work for me, but no work in spite of doing hard work. This phrase can be fitted only in this case, not work in spite of working hard. You guys are working too hard. Still, in scientific term, in science, you are doing no work, right? So no need to worry. Means you have to continue with your studies. Do not forget about anything. Just try to correlate how I am explaining you that in day-to-day life we are using work for different terms. Any physical and mental labor is considered to be work in day-to-day life. But in science, it needed certain conditions to be justified. In scientific way, we have to justify the proper physical quantities, and then we will give you the definition of work, right? So how and when it will be explained that you are doing work. Now next example. For me, you have done work in day-to-day life, but in scientific way, you have not done work during your MCQs, right? So, who those are now not scored in this MCQ good marks, so they have not worked according to day-to-day life as well and scientific way as well, right? So now you have to work, dear students, to make your marks high and for better understanding. Okay. I'm not saying that you should run behind the marks, but you should learn for your better understanding. Okay. So now pay attention. Each suppose you find mountain. Okay, let mountain. You just try to push the ball of your hole. Okay, continuously push. You ate three rotis in place of one, and continuously from morning to evening. You just push the ball. And tell me, have you exhausted? Of course, you will stand there for 5 minutes also, you will get exerted. Not exhausted, but exerted. You will get very tired that I'm doing some work. According to you and me, you were standing there and you were doing work. Or you will stand there and you will do work. But the stone has not shown any displacement. Similarly, the ball has not shown displacement. Your bedroom has not turned into the hall, right? It remains as it is a bedroom, or hall has not converted to the ground. You are not shifted that ball actually. You are not Superman. Of course, I'm not Superwoman, so we have not done that work. Means displacement was not there. Right? Similarly, another example. Suppose you are standing with a heavy load on your head, right? And you are standing from morning to evening with that load. Of course, you will get exhausted, right? Exhausted. Sorry. You will get exhausted, you will feel tired, you will get a sound sleep at night. But what? By the science, you have not done any work because you was at the same place. You have not covered any distance or displacement at that place. Means you have not done any work. For me, for your mom, for yourself, you have done work in day-to-day life. But for science, you have not done work. But if you are standing on the lower step, on the ground, and you climbed up to the first floor, right? Just to see the landscape. You just went up the floor and saw the landscape, or even you climbed up to the tree for having mango or apple. Right? So at that place you move from ground floor to the first floor. You have covered some distance and thereby you have done work in that place. So it is to be understood that behind the scientific concept of work, again, we will explain some examples here. Yes. One more example we can say, suppose a pebble or a small, very small stone, pebble, you will get that idea, right? Escaped on a surface and you just pushed it. If you push that pebble which is already on the floor, of course that pebble will travel some distance and you have exerted force on that pebble and that pebble covered some distance. Means there is the movement, there is a force, means work to be done there. Similar next example, suppose you are moving in the market, right? Nowadays you are not supposed to do that, but just we can imagine, you just feel for a while that you are in a market, you are purchasing or doing shopping for yourself, right? Of course you will enjoy shopping, but you have to purchase a lot of course after lockdown period, you are waiting eagerly to went out to have shopping, right? Especially girls or me. So you will go to the market and you need a trolley for your that objects or clothes what you have purchased to get. And you are pushing that trolley with you. Of course, trolley is moving with you. You are exerting force on the trolley and trolley is moving with us. Means we are applying force and displacement is there. Means work is being done by the trolley, by the on trolley by the us. Right? And this is a concept which will lead us the conditions of work. If we have to understood the meaning or definition of work, we have to understood the conditions which required. What are the conditions required? The first, The force should be the force should be exerted on object. The force should be exerted on an object. This is the first condition. And the next is the displacement must be done by the object. Object must be displaced. Okay. So these two are the very important conditions for work. Now I know you already knew the definition, but we have to not ratify the definition. We have to logically understood the definition, right? We understood now that if we are saying, if anybody is saying in science that work has done means the force has to be applied by anyone and displacement should be there. If you are loaded with heavy force, means though the weight is there, means we know that weight is equivalent to your gravitational pull, right? Force. So F equal to mg means force is exerted, but you are standing on the same place. You will not do any displacement. Means we can say the work is not been there. The ball is at the same place. Means distance has not covered by the ball. Means what has not been done there. Right. So these are all the examples with which we can read to the condition for work, and we now understood that work has to justify two terms in detail. One, it has to apply force, and the displacement must be there. Right. And now leading to the actual concept of this. We understood that these conditions are there. Now you can lead to the term actually the force or actually the work done by the constant force. The work done by the constant force. If you understood this, then we will lead to the definition, SI unit and the definition of one joule. Okay, so pay attention. Work done by the constant force. Here, whatever the headings are given, each and every heading are so important. You have to be cautious. Constant force and variable force. There is one another term variable force, but we will not worry about here in 9th standard. We have to learn it in 11th standard, right? So not only the work is done by force, the work is done by the constant force, right? So first case we consider. Suppose you have considered a table and a ball or any object is placed at the top of the table. So force F is exerted on that ball or on that object, then that object will be displaced some distance of 1 meter. Right? So this displacement is in the same direction as in the direction of force, or in rather way. The force is in the same direction of the displacement, right? So why I am explaining you this? The word by constant force can be understood in two cases. Case 1, when the force is along the direction of the displacement, and that is what I am explaining here. The work done by the constant force, let us consider the force F is acting on an object O. The object displaces by the distance of 1 meter. Right? So force exerted is F. The distance covered instead of 1, I can write here its notation of physical quantity S. So the distance is given by quantity S. So the work done W now is defined as the product of force and displacement. Right? The work done W, this work done is defined as is equal in magnitude to the product of force into distance. Right? The magnitude of work done is equal to the product of force and distance. Thereby, we can define it as work is equivalent to the product of force into displacement, and this is a mathematical formula which we can find now by the definition of this work. What is work? Work will relate two conditions. Force should be exerted on the object, object must displaced. And by that, first case, force by the work done by the constant force. So case one, the force is along the direction of the displacement. If force is along the direction of the displacement, then we can understood the concept force given by F, distance is S, and the definition or the magnitude of work is equivalent to product of force and displacement. And now, thereby, of course, we can find ourselves the SI unit for this work. The SI unit for work in terms of force is Newton, in terms of distance it is meter. So, Newton meter is the unit of work, but altogether this unit is replaced as joule. Capital J, right? So the unit for work is joule. The SI unit for work is joule, and this is nothing but your Newton meter. Joule was the scientist who has provided. So when you are symbolizing it, it will be capital J, and when you are supposed to write this unit in yours, it will be small j, J-U-L-E. Okay. So we have written here joule. Now you're very smart. We can define now 1 joule. If you got this concept, we can define joule. Have you understood up to this? It is nothing much, but with examples only I have to explain to you. Right? Have you got it, dear children? Can I move next to 1 joule? Define 1 joule. Capital J, and this is your small j. How to define 1 joule? Okay. We have left with time. We have left with 10 minutes more. So why yesterday? It will be, of course, we have not done it yet. So there will not be any yesterday. Okay, but we have to learn it by today only or by day after tomorrow. No yesterday. Okay. So make a point here. What is 1 joule? 1 joule is what? If you will write that work done on any object is considered to be 1 joule if force exerted of 1 Newton and due to this force the object moves or displaced by 1 meter. Right? So this will lead us to the concept of 1 joule. So now pay attention to the definition. 1 joule is defined as 1 joule is defined as the amount of work done on the object. 1 joule is defined as the amount of the work done on the object when force of 1 Newton displaced that object by 1 meter. When force of 1 Newton displaces that object or displaces that object by 1 meter along the line of the action of force, right? So this is actual definition of the joule and 1 joule. It is very important to be understood. The unit you should remember and the definition of 1 joule should be remembered. It is very easy. If you know the mathematical formula, you can define by yourself, right? You are very smart and you can do it. Just remember 1 joule of work is done on the object if 1 Newton of force is applied and that object displaces by 1 meter. Considered to be 1 joule, right? So here we have covered with this point. We understood what is work, what are the conditions for work, the definition of work, SI unit, 1 joule, and more importantly, only a one case we have considered work by a constant force. Means if the force is applied is in the direction of the displacement, right? That case we have discussed here. So pay attention. I know you have to understood it with the help of force. Force is there, which is itself effective quantity. But work is not a vector quantity. Work is a scalar quantity. Work has only magnitude. Work has only magnitude and no direction. Right? And such physical quantity is called as scalar quantity. Yes, what is 1 joule? 1 joule is defined as the amount of work done on the object when force of 1 Newton displaces an object by 1 meter is called as 1 joule. Okay, so this work has only magnitude and no direction, and this physical quantity called to be scalar quantity. Still, right, on the basis of force, we can explain the positive work and negative work. See, you have to just make sure work has no direction, but on the basis of direction of force, we can understand the positive work and negative work. Have you understood up to this? Okay, so now pay attention to the positive work and negative work. What will be it? Only with the reference of example I will explain you. How can be understood, right? If suppose I have considered the same example, I have exerted a force on particular book which is kept on the desk, right? So I have exerted force and book has moved in the same direction, means force is along the direction of the displacement. I have applied the force in x-axis, the book has also moved along the x-axis, right? Means the work what will be there, it is positive. Why? Only the reason is that force is along the direction of the displacement. Okay, now moving to the next condition. If suppose, next example, if suppose I am throwing a ball in upward direction. If I throw a ball, of course I have applied or exerted force on the ball and that ball will move in the upward direction. Means what happened? The exerted force and the displacement of the ball both are in the y direction, means in the same direction, means work done in that case, or in the reference of exerted force is positive work done. But now consider the same situation but differently. You have to think differently, means that your reference force will change. Reference force will change. Suppose the book is kept on the table, I am exerting a force in that case. But now I will think about the action reaction force, right? You know that we have already learned that every action there is equal and opposite reaction, and no surface can be perfectly smooth surface. It must have some friction. So that though I am applying force to that book and book is moving in forward direction, but there must be a frictional force applied by the surface of the desk on the book in that opposite direction. Are you getting my point? With the reference of that frictional force, your book is moving in the x-axis, but frictional force is applied in the negative x-axis. Means both are opposite to each other, and with the reference of that frictional force, the work done is negative. Work has no direction. We have to just understood it in terms of force. Means the force or frictional force is opposite to the displacement. If the force is opposite to the displacement, means that particular work is negative. Right? Similarly, another example which we have understood with the help of throwing a ball. If I throw a ball, I have exerted some force on it. It will move in y-axis. Positive y-axis, displacement is there. In positive y-axis, force was there. Right? Means in reference with exerted force, the work is positive. Now at the same time, what happens? When you are providing some force, it will gain some velocity, initial velocity. Slowly it will reach to certain height. At that point, its velocity becomes zero. How happens this? Because it is always exerted by the gravitational pull. it is acted by the gravitational pull, and thereby, due to that gravitational pull, that ball will reach to be equal to 0 and comes down, right? But only during that upward motion, gravitation will pull it, and with the reference of gravitational force, with the reference of, yes, with the reference of gravitational force, what we will get? The work done means the displacement will be opposite. Gravitation is pulling downward towards the earth, and your displacement is y-axis, means both are in opposite direction. Force, gravitational force is opposite to the direction of displacement, right? And thereby it is called as particularly your negative work done. Yes? Am I audible to you? You are getting my class completely? I recognize right now that I have not used mine. So are you able to listen me because we have almost completed our chapter, our class. You are answering me or giving me answers means it is audible. Okay. So at the end of this class, I recognize I have not used my dear children. So I was totally lost in the study, right? So this is the involvement by you. I do not remember anything when I start teaching you, right? So it's lovely response from you all. It's really great that we are studying with the discussion. If you do not understood anything, you can ask me right, directly. No need to worry about anything. So here we have completed only with the part of work. So in next class, dear children, we will start with another part of energy for today. This is all from my side. Do you have any queries? You can ask me. We have 2 minutes more. Do you have any queries? No queries? Okay, just then you answer me. If suppose we have an example that you're throwing a football with your foot towards the net. So, is that the positive work or negative work? If football is kicked, if football is kicked by you, how positive Ayush? Yes, positive. There will be no negative work. Viva, is there any reference force which will give us negative work as well? Okay, so you just think about it. Yes, you are right, positive work, but you have to explain me the reference of negative work as well. So in next class, you will answer me. You just go through the theory and friction. But how friction? Air friction. Suppose air friction we consider negligible, then there will be no force. Air friction is not there, then it will be negative. It will be always positive, or any other reference will be there. Okay, so we will discuss it in next class as well. So it is something interesting to understand, right? A football is lobbed in the air towards the net. So what will be there? Yes, air friction must be there. If suppose air friction is negligible, is there any other force will be there? So that is what you have to answer me in the next class. For today, it's all from my side. So take care. Bye bye.